Hi there. I am just going through all of this news about the COVID-19 and trying to make sense about whether or not it is something that is worth worrying about or not. And it's really hard to understand all the news. Some people are telling you that it's, not near as bad as the flu, which is really bad. And this comparison to the flu kind of got me thinking about, the different numbers. So I think it's fair to say that right now, as we compare this to the flu has been around a long time. And we're just seeing this, the first cases were popping up in December and January. We had less than 100 deaths in January. Now we have, more. The number of cases was below 1,000 in January. We have over 100,000 cases worldwide as of March 2013. So anyway, my thought of as I was looking at this was to use Excel to kind of look at the numbers. I have no political bent here. I have no mission or goal to try to get people to sway their opinion. Mostly, I'm just thinking, hey, let's look at the facts and let's look at the numbers and see what it comes up with. And so the way that I was doing that, first off, is that there's this comparison that's been happening right now with the seasonal flu, and those numbers kind of come. You see them at the news outlets that are out there. But if you do look at the CDC website, you'll see that what news people are reporting right now is pretty accurate if you're seeing these numbers. So population in the United States is 327 million. Flu cases, I think in the last year was about 35 million. So if you take that and do the calculation to that, that's about 10.85% of people who were infected, which is a lot when you think about it. A tenth of the population in the United States got the flu. Now, what percentage of that caused deaths? It was 34,200 people actually died from the flu. So percentage-wise, the people who were infected, it is 0.1% of people who got the flu died from the flu. And that is 0.01% of our population. Now, that should be the numbers you're seeing. And so then people are comparing that to COVID, and they're saying, all right, let's look at COVID. So right now, as of March 2013, we have 1,629 cases. And that, if you go and look at the CDC website, I'll refresh it here. It is updated as of March 2013. There are 1,629 cases, 41 deaths. So if you take those numbers and you do the exact same calculations, we have a calculation here of, let's just do the numbers here. You divide the number of deaths, the number of cases by the number of the population. And basically what we're getting is it's like 0.0005% of our population has gotten this. It's a very small number. I've actually hard-coded it. I went ahead and took that number and calculated it, and then I just pasted the value in here, and I'll explain why I did that because I'm going to show you something called a data table. Then we have 41 deaths, and so the rate of death here, if you want to know that, it is 41 divided by the cases, and that's how we get this number. Let's format this as a percentage, and you will get this number that looks like this, right? It's 3%, or if you increase the decimals here, you'll see that it is 2.52%. All right, so that's these numbers here. You can double check my numbers, but that is basically what we see here. So infection percentage, 0.0005% of the United States has this right now. And of the people who have had it, it's 2.5% of people have died. So the rate of the population that has died from it is so small that I can't even show it. It is 0.00013. And if you compare that to the flu, it is basically I've gone here and just compared the number of deaths to, and you see that the numbers compared is like 0.12. Now, the important thing to note here is that COVID is very new and it is not finished its season, right? So we are at this beginning stage of everything, and we don't know where it's going to roll out. By the way, if you do want to know number of deaths in the United States as of 2017, these were numbers that I pulled from a website called Medical News Today. I don't know how legitimate it is. You should always question numbers that aren't on a legitimate website, or you don't know if it's legitimate. It says right here that heart disease and cancer are the biggest causes, and that it was 247 deaths in heart disease. That seems to line up with the CDC's website as well. So I assume these numbers are correct. I'm just throwing these out here to show you that the flu right now does not even account for a top 10 killer. And so these are the top 10 things that cause deaths in the United States. And again, I'm not doing this to point out an exact, because I do not think it's an exact apple to apples comparison. When you compare COVID-19, which is currently in its kind of second to third month, to the flu, which has gone, to an entire complete flu season. So the question here is, what happens if we change these numbers? What if the death rate stays the same, but the infection rate goes up? So what if 1% of the population were to get this? If you do that, you see that, hey, based at a 2.52% death rate, we would have 82% or 82,000 people die from this. And that would be 240% or 2.4 times more than the flu. So but then you could also say, well, what if it's 1%, but the death rate eventually goes down, right? What if we find that more people have it, they don't die from it? What if the death rate is only, 1%? And so we have 1% of our population gets it, and 1% of those people die instead of 2.52. Then you'd see that it's 32%, 32,000. Again, that would actually be less than who die from the flu. So the question here is, what is the percentage of people in the United States that are going to get this? And what is the ultimate death rate that we are going to see? Is it going to go up? Is it going to go down? Some people think that early on, because we aren't because the testing is just now ramping up and we haven't tested everybody, there could be people out there who have COVID-19 who we don't know of. And so if the number of cases goes up, but the number of people dying doesn't increase at the same rate, then we might see the death rate goes down. So this is the perfect opportunity to talk about something called a data table. So a data table basically looks at, okay, what if we have what are all these different variables that could change? And what happens if these variables of the death rate, go from anywhere from like where it is currently down to 0.1%, which is what the death rate of the flu is. And then how do we balance that with the infection rate? And so if we can look at these two numbers and think of every possible scenario here, which is, if you look at this, this is 14 by 13 here. So if I do the math on that, that is 182 different possibilities that we're just going to throw into this table. Now, let me show you exactly how a data table works. This is actually a really simple example of how we explain it in the business school. So what we'll say here is that, let's say you actually contribute 10% of your salary and your salary is $50,000. If you contribute 10% of your salary every year and you get a interest growth rate of 7%, then at the end of the first year you will have 5350. And so then next year you're going to take that ending balance, you're going to contribute another 10% of your salary, and then the interest rate will grow. And so you can actually see what would happen of like, what if I only contribute 5% of my salary and the rate of growth is 4%? So you can see how it would change. The average interest rate on maybe an index fund can range between 7 to 11. Those numbers, again, people can debate those numbers. My goal here is not to debate the percentages, but to just say, let's look at all of them. Again, what if I gave 15%, or let's say, or 10% of my salary? So what a data table does is says, all right, let's just do all of the math for you. So let me just quickly go and grab a data table, and I will tell it that, okay, so the row input here will be this contribution rate, and the column input will be the interest rate. So basically what this is going to do is it's going to run the numbers, and it's going to change this number here that I'm linking directly from the bottom here, and it's going to run every possibility and put them into a table. Now, the one thing that I do run into sometimes is that we should see these numbers work out. So if I have an interest rate of, let's say, 7, which I have over here, and a contribution of 10, this number should match this number. And if it doesn't, it's because I got my numbers backwards. And so, what I'm going to do is I'm going to go back here, and I'm going to fix this, and I'm going to switch what I did. So instead of the row input, I'm going to use this as the row input, and then for this, I'm going to use this as the column input. And let's test this. So the contribution rate of 10 at a rate of interest rate of 7. So there it is. So that matches that. And so what this is telling you is that if your interest rate is at 11 at a contribution of 10%, then you're going to see, instead of 505,000, just by an increase of 5%, you're going to see it go from 505,000 to 1.1 million. And this is like a model that would tell you, hey, what is a retirement account going to have in it based on these variables? So it's thinking of all of these possibilities. So let's do a data table with COVID-19. So the thing is I tried to think about what is the reasonable death rate to put in here. So right now, the current US death rate for this is 2.52%. Now, some people say that it's very common in a pandemic that the death rate is higher early on, because once we start to test more people, we're going to find that more people have been infected, and so it's possible that the death rate will fall. The current death rate in the world is 3.75%. So if you take the cases out here that we have, I'm going to go ahead and throw these numbers out that I pulled from this Worldometer website that I found. And so this is the current Worldometer count right now of total cases, deaths, and number recovered. These numbers, I don't know exactly what date they came from. It looks like March 14th. Again, if these numbers are right, and it's always possible that they could be wrong, then, but I'm taking these into account. So just, I'm trusting these numbers. And so what I did here is I grabbed all of like China and Italy and Iran and South Korea. I looked and basically kind of calculated their percentage of their death rate. I also looked at, and this is based on their total cases and total deaths. I also looked at the percentage of their population that has it, and I'll come back to that here in a second. So if I go back to my numbers, what I did is I kind of just said, okay, let's look at the current death rate and let's subtract it by 0.25%. And then what I also did is I threw in the death rate that we're seeing at other countries. And so those numbers came from, all the death rate numbers came here. So we have the worldwide death rate, which is 3.75%. We are actually below that. We are currently, let's see here. I don't know why this is, that is, I must have messed up my numbers here. I think it's because so let's go back here and let's fix that number. US is total cases and total deaths. Now, I would say that these numbers look a little different than what we're seeing on the CDC website. So I'm going to actually do this. I'm going to go off of the rate that we have here. Let's go back and grab those numbers for a second. And currently right now it is 1629. So I'm going to put that right in here. And it is 41. So let's get the right numbers part of the whole. There we go. So 2.52 is what we have in the United States, according to the CDC. If we go and assume that it is going to drop, which hopefully it will, then we will see that the death rate goes lower. So I've kind of considered all the possibilities. I also pulled in the death rate off of this website from South Korea. So they have 8,000 cases and 72 deaths. So they have a lower rate right now than we do, but they might have had it longer, and because we have a lower number. So this might be a good indication that, as the number of cases grow, the number of deaths will actually decline or grow at a slower rate. So hopefully we'll see something like this with South Korea. Germany actually has almost twice as many cases as us, and they have a lower death rate. Singapore and Canada, right now they have 0.5% in Canada, and Singapore has a 0% death rate, which is pretty amazing. But again, the numbers they have is like 200 cases. So we don't see the same number of cases. So you want to have volume sometimes with your data when you're looking at these rates. China and Italy's rate, you'll see Italy's rate of death is 7.17. It's pretty big. So, okay. So I took into account all these different death rates, and you'll see here I pulled in Germany's, I pulled in South Korea's, I pulled in the United States, I pulled in the world average, and then I even went down to 0.1%, which is the flu rate death rate, the flu's death rate. So we're going everywhere from 0.1%. And keep in mind, we can't go, there's no point in calculating zero because we already do have deaths in the United States. So we're already looking at, okay, the lowest, I'm ballparking here. And again, I'm not pushing anybody in any direction. I'm just saying, what's the worst case scenario? Let's assume that it's as bad as the flu. And you might later on say, hey, Clint, it's not going to be as bad as the flu. Maybe it's 0.05%. But I'm gonna start with the low end of 0.1% death rate. And keep in mind we're at 2.52 right now. So if it goes as low as 0.1%, and it goes as high as the world average. So that's assuming that worst case scenario, the death rate actually goes up. But again, from what we hear, that hopefully it is going to go down. All right, so there's how I came up with all these different rates. And keep in mind, this doesn't like slide at an even rate. And then also I have the next variable, which we're going to change, which is the percentage of people that are infected. So at the lowest end, we know for a fact that right now, the percentage of people that are infected with this is, and let's go back here and let's do our numbers here. This is the actual death rate. I'm sorry, the actual infection rate, and we know that the death rate right now is actually 2.52%. All right, so we know right now that's where we're at. So we know that it's the percentage of people in the United States that are going to get this can only go up, right? We don't know if it's going to. I mean, you could make an argument that okay, it's going to stop and no one else will get infected by this. But because we are in a state of emergency and we are rapidly testing, most people will agree that as we test and we're going to find more cases. So the percentage of people that are infected with this is going to go up. Just the infected, not death, but just infected. So when I went back and looked at these numbers on Worldometer, and again, you can question this website. I'm just taking the numbers that I found here. The average rate that right now at this point in time, and keep in mind it's about 2 to 3 months into this whole thing, the average rate of population that has been infected is like 0.01%. So if you go look at like Italy, 0.02% of their population currently has this. So it's like 292 for every million people. In China, it's actually 0.005, right? So 56 cases for every million people in the population. So what I did is I looked at what is the min of that, and this is taking into account the top 15 countries based on volume of cases. So I took 0.000, so the minimum is 0.0006. That is Japan. Japan right now has, for every million people in its population, 6 people are getting it. That's pretty low. The average right now is 0.01%. The max, which is Italy, is 0.02% of the population is getting it. Now, again, this is early on, so this percentage will likely go up. But what I did here is I said, okay, based on the current rate of infection, which is what we have right now, it's 0.0005% of the population has it. If we go to Japan's rate, it's actually pretty low. It's 0.0006. If we end up getting to the average, it's 0.01% of our population gets it. If we get to the point of Italy, where 0.02% of us have it, we'll consider that number. Then I just kind of went through and said, okay, what happens if 1%, 2%, 3, 4, 5%? What happens if it's the same infection percentage as the flu, which is 10.85%? What if it's double the flu? And then I'm throwing these numbers in here because I heard this on a couple of different news outlets, and I would say that we take these numbers with a grain of salt. But people have said, like Germany is saying, oh, well, we could see 70% of our population get this. I don't know where those numbers came from, and so take them for what you will. But I'm going to throw them in here. I heard this range of 40 to 70% of people could get it. That might be total BS to you, but I'm throwing them in just to show you again how a data table works. So now that I've got this, I'm taking this number of deaths, and we're going to calculate out using a data table, and we're going to go back in here and say, all right, so now for some reason, when I do this data table, my row input actually works out as I want it to. So the row input here should be the infection percentage, which is this number here. And so we're gonna swap that number out with all the different possibilities in this table. And then the column input will be the death rate. And that will, again, we're gonna swap out this number here for every number in this table. And when we hit go, it's going to calculate all the possibilities. Now, as we look at this, you can see that if we stay at the current death rate and we, let's say, get to 1% infection, you're going to see that the number is going to be 82,000, right? And so what this is showing you is, we need to watch what is the rate of death of people who get infected with this, but then also look at the percentage of people who get it. So that's the big thing right now, is we're trying to reduce the amount of people who are getting this thing. And then obviously we're going to try to reduce the death rate by trying to create some kind of treatment or some kind of vaccine or something like that. So these are all the, so again, I have no agenda here, but I will say I see this number comparison to the flu, and I think that's probably a little premature, because that's like comparing, the intelligence of a 5-year-old to a 50-year-old, right? You just can't do that, because we haven't seen the lifespan of, where this thing is going to go. But we do know that if the more people who get it, and based on the death rate, we are going to see the numbers go up. So what I did here is I'm going to do one more thing, a little conditional formatting, and I'm going to say if the number here is greater than the number of deaths for the flu, highlighted in red, and then if the number of deaths on this table are less than what currently the flu number of deaths is, show it in green. So what this is showing you is that, okay, if this COVID-19 has an infection rate of 10.85%, which is what the flu has, and a death rate of 0.1%, which is what the flu has, you'll see that we'll see somewhere in the range of 34,000 people will die from this. And so obviously the extreme numbers that people are saying, like, Germany says, hey, 70% of our people could get this. Well, that means if 70% of people got it, but and it had the same death rate as the flu, that would be 220,000 people in our country would die from this. So you have to kind of like look at these numbers and say, what if we end up having the same death rate as Germany? And what if our actual infection rate stays, closer to the average infection rate? Well, then that would mean 68 people would die from it, meaning only an additional 27 people would die. But you can see the extreme variability here, and that's what a data table is kind of showing you, is all the variable possible options, right? So again, if our death rate goes down, which we hope it does, so let's say it is cut in half, and we only see 1% of our population. And this is where I think it's kind of interesting, is this middle ground, is what if our death rate goes down to cuts in half? Or let's even say that the death rate, like South Korea has had it a little longer, they have more cases. What if the death rate matches that of South Korea? We assume they're an industrialized nation, they are addressing this, they're testing, they're doing everything, so they've kind of got a head start on it. What if our death rate, matches that? Then the question is, how many people are going to get it? So if it's 1% of people get it, then we're going to see 29,000 deaths, which is less than the flu. If 2% of people in the United States get it, at this death rate, we'll see 58,000 people die from it. If we go match closer to Germany, which Germany right now, again, has twice as many cases, but very low deaths. Again, Germany and we have similarities in our countries in terms of our ability to potentially fight this. So maybe we are going to be at a death rate of 0.2%. But again, we would have to be infected up to the rate of what flu infection is to see more deaths than the flu. So at the end of the day, the question is, are we going to see this thing spread more than the flu or less? And then are we going to see the death rate be more than the flu or not? Which right now, we currently have that a death rate of 2.5% compared to the 0.1 of the flu. But again, right now we've seen a much lower spread rate. So these are the numbers. That's what a data table does. I couldn't help but geek out and play around with it, because when I think about these crazy things that are happening in our world, I like to go to Excel. I like to look at the numbers. So as the numbers change, I'll keep updating this model, but I hope this was informative, and I hope that you enjoyed learning a little bit about Excel, conditional formatting, and data tables. And until the next time, I'll see y'all later.